Hello everyone. So today in this video we'll be covering up a problem from INPHA 2022 or more specifically IOQP Part 2 2022. This problem is from this chapter of Mechanics and SHM. So let's get started. The question says that we have a block of mass m which is equals to 0.1 kg. So the mass of this block is 0.1 kg and it's also given that and it is attached to a spring whose one end is fixed and other end is fixed to the block, whose spring constant is k equal to 50 Newton per meter. Given that the block slides on a rough horizontal table along the x-axis, assume that the coefficients of kinetic and the static friction to be same and constant, which is equal to 0.25. The block is initially displaced to x equal to 0.1 meter and from the unstretched position as mentioned, and the normal length of the spring is at x equals to 0. As mentioned, the unstretched position I am marking by blue color, that is this one, is the unstretched position. Now you have to neglect the air resistance and answer the following question. First question says that how many times the block will cross the unstretched position before coming to permanently rest. Second question says determine the total distance covered by the block before coming to the rest. Third question is a bit bigger one and you have to basically do some analysis and comparison. And fourth question is about rough plotting or a rough graph plotting. So let's get started. First question is how many times it will cross the mean position, means x, basically x equals to 0, not mean position, I'd rather say. First we need to find the mean position when block is going to the left direction. That is, block is the spring is stretched and block is moving towards the left. In that case, a friction will be acting which is constant in magnitude, and that is mu mg. On further evaluation, we'll get 1 by 4. Mu is given as 0.25. I can write it as 1 by 4 into 0.1 into 10, which will come out to be 1 by 4th meter. Basically, now there will be some apparent mean position. Means when the block will be going leftwards, the mean position will be shifted from x equal to 0 to some x equal to positive value. Now what will be the mean position? Just evaluate with 50x. You will get x equals to 0.005 meters. So x equal to 0.005 meters basically represents that mean value when the block is going towards the left direction. Similarly, another position, that is x equal to minus 0.005. This represents the mean position when the block is moving towards the right direction. Now, what will basically happen is that when the block is moving towards the left direction, initially it will have the amplitude of oscillation equal to 0.1 minus 0.005. It will go further by the same distance in the negative direction, that is 0.01 minus 0.005. Now, this is the distance from the apparent mean position. Now, what will be the distance from x equal to 0 to the extreme position? That will be 0.1 minus 0.005 minus 0.005, which will come out to be 0.09. So, this is a very nice observation that first the block is at x equal to 0.1, then it will go to x equal to minus 0.09. Again, it will go to x equal to plus 0.08, because in each successive oscillation or in each successive change crossing of the x equal to 0 or change in the direction, the decrease in amplitude will be by a value of 0.01. So then again it will go to x equal to plus 0.08, then it will cross the x equal to 0 at by 2 times. So first it will be 0.1, then it will go to minus 0.09 first time, then it will go plus 0.08 second time, then 0.07 third time, and so on up to 0.08. It will have crossed 0.01. It will be about ninth time. it will have crossed. Now 10th time it will go to 0.00. Now we'll consider it up to 9 times, because at 10th time it will just touch x equals to 0 rather than crossing it. So the value of n will be 9. This is my first question answer. So the answer to part A is 9. Second part is determine the total distance covered by the block before coming to the rest. Now this part has two methods. First method is just add the amplitudes of the motions during each interval, that will be 0.1 plus 0.09 plus 0.09 plus 0.08 and so on. This way you will get answer to be about 1 meter as far I remember. And second method is work energy theorem, that is half kx naught square is equals to work done by friction, that is mu mg into s. So s will come out to be 50 into 0.01 by 2 into 1 by 4th into 0.1 into 10. Then multiplied by 2 we'll get 1 meter as the answer. So this is the solution to the second problem. Now third problem is a bit bigger one. What does third problem says? Third problem says that we divide one complete oscillation of the block starting from fully stretched condition of the spring into four distinct sections. T1 is the time taken for the block to move from fully stretched to unstretched position. T2 is for unstretched to fully compressed. T3 is for block from fully compressed to unstretched. Then T4 from unstretched to fully stretched. Let the distances covered be D1, D2, D3 and D4. Okay. Now I am considering a sample time when the block has amplitude of x equal to a, means block is at x equal to a, and this is the sample moment I am considering about. Now during the leftward motion, since t1 is defined as the time interval for covering up to x equals to 0, so during the leftward motion this will be the mean position. So this is mean position for time 1. Now what will happen is that we will consider a phasor diagram. We'll consider a phasor diagram in which the circle will have radius of a minus x naught, where x naught is the mean position as I defined in the previous section where I was doing the calculation for part A. So x naught is basically 0.05. I'm not taking the value here. So what will happen, basically we'll draw a phasor, and the angle covered by it will be this plus the 90 degree. So it will cause some time t1, and the radius is a minus x naught. This is equals to x equal to 0. And what will be theta? Theta will be sine inverse x naught by a minus x naught. So t1 will basically be pi by 2 plus sine inverse x naught by a minus x naught by omega. So this is t1. Then what will be t2? T2 is basically during from here to here. T2 will be pi by 2 minus sine inverse x naught by a minus x naught by omega. So this is second and this is first. Now the block has reached here, that is the most compressed state. Now there will be a switch in the mean position. Basically the mean position will be the second line. This is the first line as I said. Here is the second line, and in this case the amplitude will be a minus 2x naught. So for this T3 will be pi by 2 plus sine inverse x naught by a minus 2 x naught by omega, and T4 would be pi by 2 minus sine inverse x naught by a minus 2 x naught by omega. Well, I'm not asked about T4 here because in the question it's defined, but in during the comparison T4 is not given. So only these first three are important for me. The first comparison is between T1 and T2. See that the phasor angle covered in T1 is greater than T2. So T1 will be greater than T2. And between the comparison between T2 and T3, we have same negative sign. Well, here it will be a negative sign. Pardon. in comparison between T2 and T3 there is a negative sign. Now we have to check that which angle is more. Observe that a minus x naught is greater than a minus 2 x naught. Since it's in denominator, so this sine inverse x naught by a minus 2 x naught will be larger. Thus pi minus sine inverse x naught by a minus 2 x naught will be smaller. So T3 will be smaller than T2. Um, just a minute. Now in this case the denominator in case of T3 has decreased, so that basically the angle covered will be more. Actually here will be a T plus only. Sorry. So T3 will be greater than T2. Common sense. Now between T1 and T3, observe that the denominator in T3 has decreased, but the denominator in T3 is lesser than the denominator in T1 in that sine inverse term. So basically the angle in T3 is more than the angle of T1. Thus T3 will be greater than T1. So this is my first part. And second part says you have to basically compare the D1, D2, D3. What is D1? D1 is defined as the distance covered during the intervals T1, T2, T3 and T4. So D1 is basically this distance T1, D2 is this, then D3 and D4, and D4 will come out to be, I guess, this will be D2, then D4 will come out less than D1. Of course, D2 will be greater than D4, one can say, because let me just extend it a bit more. So D1 will be greater than D2. It's easy to observe. D2 will be greater than D4. Yeah, you can prove. You can prove by the manipulation I have done in part A. So these two are solved. Now comparing between T1 and T2, T1 and T2 says the time interval to complete the first and the second oscillation starting from the initial displacement. Now overall, a angle of 2 pi is covered in both of them. So basically T1 is equals to T2 because time period will be 2 pi by omega in this case, right? Hope you get it. Now the last part says you have to plot displacement x versus the time graph. Yeah, this question is also a nice one. Now I have to first make two axes, x axis and y axis, where x axis represents the time t and y axis the displacement x. Suppose this is my mean position with respect to left and right motion, and this is my initial amplitude a. Let me shift it a little downwards, x naught, a little bit closer. Yeah. So at first, the above x1, the x1 which is in the positive y-axis or the x-axis, you can say the displacement axis, will act as the mean position. So it will be basically a cos curve with the zero axis to be at x y equal to x naught. So this will be my first motion. Now here the block comes to at rest temporarily. Then now the negative x naught will become the zero axis for it, and it will go as per this. Then again the positive x naught becomes the axis, and it will basically be a series of cos curves and so on, and it will eventually merge. Okay, hope you get it. I hope you understood this problem, and I am posting another problem in the description as well as in the comments. This problem is from NBPHO, past problem from NBPHO. Well, this is from LC oscillation, but you have to figure out that how this problem is related to the NBPHO problem. Well, there must be some mystery here, and I want you to find out. Hope you enjoyed it. Thank you, and have a nice day.